Buying or building a computer is a difficult topic. So you'll need to understand what you're getting yourself into, different components you might need, what different things mean. It's difficult, it's complicated. So I'm here today to help inform you so that you understand what you're getting yourself into, what you're buying, what things mean. So to start out, let's talk about what a computer has. A computer has a CPU, a graphics card, a power supply, motherboard. It's got memory in it, and it's got some type of storage device. But you guys probably don't even know what those are. So for my first point, I'd like to introduce what everything is. For my second point, I'm going to go over some different terminology for different storage devices. And for my third, I'm going to talk about different CPU terminology. So bits, no. So different types of components. You have your CPU, I already explained all that. Your CPU is like the brain of the computer. It does all the processing, processes all the information, it goes through everything. You have your graphics card, which are kind of like eyes. They allow you to see things, they display the information on a monitor so that you can understand what's happening. You have a motherboard, which is like a highway. It allows different parts of your computer to communicate with other parts. Your power supply delivers power, obviously. Your memory gives your CPU and other components very fast access to different storage that otherwise they'd need to go all the way to a different storage device, which is much slower to access. That's why we have it, just so we can have it quick. And then we just have our long-term regular storage, which could be a hard drive or a solid-state drive. They store things for long times. They're much slower than memory, but also have much more capacity. Let's start out by talking about different types of storage. So computers talk in forms of bits. That's how they communicate. A bit is either a 1 or a 0. It's in binary form. You're probably used to the base 10 system, 0 through 9. When we use 1s and 0s, we determine on or off. As the University of Information Technology Services puts it, a bit can hold one of two values, 0 or 1, corresponding to the electrical values of off or on, respectively. Each bit has its own value of 1 all the way up to bits are grouped into groups of 8, which make 1 byte. So that value of 8 gives it 128 possible outputs. I mean, sure, if they use the base 10 system, there'd be much more, but they can only communicate with off and on. So by using 1s and 0s, they make bytes, and they store in the bytes and bits are the base systems. So obviously, with how advanced computers are nowadays, we're going to use something larger than just a bit, just a byte. We use different scaling. So a kilobyte or kilobit would be 1,000 bits or bytes. A megabit would be 1 million bits or bytes. And a gigabit or gigabyte would be 1 billion bits or bytes. And then that goes on and on and on and keeps going up. The things that store these bits and bytes are different parts of the different components, like the graphics card has its own special type of memory, its own special RAM. That's to store video information that it'll need quick access to. While regular memory is, again, as I stated earlier, just quick access to information that they can't access or that they need to access quickly. Then there's your regular long-term storage, hard drives or solid-state drives. Whatever you choose, a solid-state drive would be much, much quicker, has no moving parts, unlike a mechanical hard drive, but they're also much more expensive. Now that you have a basic understanding of how bits and bytes work, let's talk about different CPU specifications. Your CPU has many different numbers and blips and bleeps and doodads all on their websites, but what does any of it mean? Well, CPUs are usually measured by their clock speed when you're comparing performance. It's based off of however many hertz, how many clock cycles per second it can go. As Intel.com defines it, the clock speed measures the number of cycles your CPU executes per second, measured in gigahertz. If you were paying attention earlier, 1 gigahertz would be 1 billion hertz, 1 billion cycles. But that's not the only thing that impacts your CPU's performance. You also have cores. Each core is like its own small little CPU within a larger CPU. They do their own tasks. They help work together to make the overall process faster. In games, you don't really need many cores because you're running things, you're not really going ahead, you're not working on multiple things at once as much. You're just trying to make one thing go really fast. But if you're streaming or video editing or anything like that, any production, you'll want more cores so that you can work on multiple tasks at once. A good CPU generally has around 4 gigahertz of processing power. But a mid-range CPU will also have around 8 cores in it. There are some lower-end CPUs, quad cores, they only have 4 cores, as the name suggests. And then the high-end CPUs, generally around 16, maybe 32. But then there's the server CPUs. Those things are massive. They can have up to 128 cores, 128 different processes working at once. So after we look into cores, there's this thing called hyperthreading. Hyperthreading allows the CPU to keep busy. It keeps information going through each of the cores. It keeps it going, running faster, which all helps to make your CPU faster. And there's so much more to a CPU than just that, but I can't get into all that within my time frame. So I hope that you are all more well-informed about how different specifications, different terminologies affect your system, so that you have a more informed buying process the next time you choose your computer or your computer parts when you go out purchasing one. Thank you.